mentioned, we're going to talk, the COVID virus, the COVID-19 virus, and our role in providing screening technology to identify people with fever. I am quite familiar with this. Every couple of years or so, there'd be another outbreak. It started with the avian flu, and then there was SARS, and then there's MERS, and there's in Asia in particular, with my prior company, we sold millions, literally millions of dollars of infrared cameras to protect populations from super spreaders in the early part of an outbreak, a virus outbreak. So when you're flying into Hong Kong, you can ride up the escalator and see cameras. You can see them at the airport in Taiwan, and they're fairly accepted. And typically at airports and places of entry, train stations, etc., in these locations. But times are changing. The U.S. really never got into IR cameras for screening, but it's all changing now because the business is now changing from looking at borders to protecting worker populations, because we're now in the community transmission mode. I just took these notes this morning. Some of you might be aware that company Smithfield just closed its Sioux Falls, South Dakota plant. I think that was today or yesterday. 293 out of 3,700 Smithfield workers tested positive for COVID-19. These workers, they work, elbow to elbow, processing and meat packing. And this one plant produces almost 5% of the nation's supply of pork, and they're down. And the guy who runs this plant is signaling about problems with the food supply in America, in particular the meat supply, that's just very seriously threatened by this virus. Tyson a week ago closed a pork plant in Iowa. So, and this happens. News like this comes out, the phone starts to ring, and now every meat processing plant is asking the question, how do we do this? How do we keep infection from crippling our workforce and endangering our employees? This is happening today. This is fresh news on these plant closures. We have a lot of examples of these corporate purchases, but again, the point I make here is that we're into true community transmission mode here in the U.S., which means manufacturing operations are just a fantastic target for this technologies. Hospitals and healthcare as well. We sold a large number of cameras to the City of Hope, which is a very prestigious research hospital in Northern California. They're checking people before they come in to visit their loved ones, or just healthcare workers day in and day out are screened every day in this tent that's placed outside the facility. Government buildings as well, up in North Dakota, or Bismarck, I believe. We sold 4 XI400s a week ago. Government buildings, schools, and universities, as they consider how they're going to manage the return to school in the fall. You can bet that they're going to be looking at solutions to make sure that the entire school population is not threatened by students that have fever. So the opportunity for these cameras is substantial. I spoke to the salesman who managed this sale to North American Stainless Steel, and this was an interesting situation. And North American Stainless, recognizing that this problem was compromising the reliable production of their stainless steel, they put in forehead temperature measurement units. So they had the security guards at the gate measuring the forehead of every single person that went in the facility. And that meant that the normal process, which took 15 minutes for everybody to make it into work in the morning, took 2 hours for them to go through, stop, and make the forehead measurement on every single person. So the president, who happened to be a friend of the salesperson in the area in Kentucky, asked our salesman, gee, what can I do about this? And they installed infrared cameras, PI 400 series cameras, mid resolution 382 by 288 camera, And now, instead of taking 2 hours, they can run 1,500 employees into the production facility in 18 minutes, and they love them. The guy said it paid for itself in the first day. I mean, when you recognize that number of employees, you're paying on an hourly basis workers that in many instances at this plant are making close to 6 digits. You're paying for them to sit in line, and you're not producing when they're sitting out there in their cars waiting to get their head scanned. So they are just crazy about this application. It works very, very well. The first day they found in that 1,500 employee count, they found 5 people that were over temperature. And they began to realize that there were certain situations that would create this alarm where someone was measuring over 100 degrees in the tear duct area. And a good example would be somebody just has the heat on high in the car. They would bring them out, go through secondary testing, make them sit in a controlled area for 5 or 10 minutes, take them offline so the cars would continue to roll through, and then they would get tested at a second level. If they still didn't pass, they would have an oral thermometer. So 4 out of the 5, they either had a hat on or the temperature was high in the vehicle. If you keep your hard hat on, or if you have a hat on, your temperature is going to be higher. So people that had these caps on, which is very popular with our young people today, to wear these caps even when it's hot outside, they're not going to measure the same as everyone else. They'll show to have an elevated temperature. They did find that in 1 out of 5 cases, this guy had a very significant fever that was validated with an oral thermometer. So they took him offline, and he didn't infect the rest of the workforce. So they are thrilled with how this is working. So very, very important how you promote this. You really can't be telling your customers that we've got the COVID diagnostic device. This is dangerous. We don't diagnose COVID. We don't diagnose influenza. And we don't necessarily claim that we can detect every single subject that has even a very, very minor low-grade fever. And you need to bear in mind that this particular virus does not always manifest itself the same way in every single person that it affects. Some people, as you've heard, have very minor symptoms. So be careful about saying that we will find everyone with COVID with this camera. That said, the camera is extremely sensitive. You can detect even subtle temperature increases with the camera. I'll just give you a look at an infrared image here for just a moment. And you can see here, I'm just touching my head with a little bit of moist water, and you can see how the temperature is changing on my forehead. So you're seeing literally tenths of a degree temperature variation here. This is what you see most commonly. And again, you can see these areas on my forehead that are just a little bit moist. I'm measuring one at about 90 degrees and the one right next to it at 94. So very, very subtle temperature variations are very visible on the camera. This is my image right here, and I have an area over my entire face. Might want to narrow that up a little bit so I don't catch anything behind me that might impact the measurements. But I'm measuring about 97 degrees right now as a high temperature inside this box, and this is a very normal temperature for me and for most people. This is very easy to arrive at. It's looking at the software is looking at every single pixel inside this box, and it's discerning what the hottest temperature is. A more common mode for fever detection you've seen before. You set the camera to black and white mode, and we actually have set up. Chris has prepared a number of what we call layouts that go through these changes automatically. You don't actually have to be exercising the software as I am right now. I'm going to establish red as a color that I want to highlight in all temperatures that happen to be, let's say, over 90, 96. Okay, so in all temperatures that are 96 will show up. So this is kind of average. As I said, my tear ducts are 97. Some plants would actually go through and only highlight those temperatures that represent a fever condition. So let's just say in this case, we want to alarm at 99 degrees Fahrenheit. Okay. So because I don't have a fever, there's no color. But if you had a manual inspection, as they do at the stainless steel plant, where instantly the security guard can see that someone has red on their face, they immediately go to the second tent for a second level screen. So color is a very easy way if you have a security guard that's participating in the screening process. If you don't and you want an audible alarm, it's very easy to set the camera up for an alarming scenario. And these, again, are all loaded in what we call layouts or templates that preset all the things you see me going through right now, so you don't have to do it. So I can define a very specific alarming scenario for area 1, which is on the screen right now, and have it signal an audible alarm on the computer or send a signal to a PLC. So there's a lot of different options for alarming. And what you will find is that some customers are very comfortable with manual screening, like the stainless steel plant. Some customers really want to hear an alarm. Some customers will want a light to go on, and all these are possible using the software we have and the digital and analog outputs. So on the right hand side of the screen, you can see that there's a color scale, and the color scale starts down at the bottom at maybe 72 degrees, 73 degrees with dark colors, and it moves all the way up until you're at temperatures closer to 100 with the light shades of yellow and white. As you graduate from those two temperature extremes, you can see how the colors change. So it's easy to see. The purple color on my forehead is a cooler temperature. The close to white temperature on my tear duct represents the hottest temperature in the scene. So what do the tear ducts tell you? The tear ducts are telling you your temperature, the closest temperature on your forehead that's correlating with your core temperature. So even though I might measure 98.6, I might measure 97 as an average or normal temperature on the outside of my face. But when that temperature happens to be 99 or 100, then I have a fever. So it's telling me I have a fever in the same way a thermometer would. It's just a different baseline than core temperature. So, and we're not saying that we can replace oral or other internal temperature measurements. If you receive a quote on this, in fact, you might want to consider incorporating this on your own quotes to customers. We like to say that the infrared cameras are a useful screening tool, and they augment, they don't replace the use of internal temperature measurement technologies that have been used forever, like a mercury thermometer. This gives you a way to do just what I was describing with the application at National Stainless Steel. They give you a way to very quickly determine whether someone is a little bit higher than the rest of the crowd, allowing you to call them aside and go into a more traditional temperature measurement modality. But you can promote fever screening, fever inspection. You can promote highly sensitive infrared images and measurements. We can see even the slightest temperature variations from person to person, and that's what makes this technology so valuable for this application. Incubation periods. Be aware that you can have COVID-19 and be fully infected, and the fever will not manifest on average to 5.1 days. So we can't detect fever if it's not there. So important for you to appreciate that. Sometimes it goes as long as 12 days before it manifests itself. The good news is the COVID typically manifests in fever. So you have a good chance of finding someone if they had COVID-19 and they're outside the incubation period. A lot of times you'll get questions from someone on accuracy because the medical definition of a fever is when you're at 101.5. And if the camera specification says 2% or 2 degrees, well, that kind of puts you into the mode where you don't really know whether or not you have a fever if you look at it that way. However, it's important also to appreciate that the cameras are sensitive to 80 millikelvin. That means they can see temperature variations less than a tenth of a degree, as you just saw on my forehead. So what we're really leveraging here in terms of the camera's capability is the sensitivity to see that someone is hotter than somebody else. And if someone is 2 to 3 degrees warmer than anybody else, we know that they have an elevated temperature. And the approaches that we're deploying inside the camera software are doing just that. They're helping you see people that have a 2 degree Fahrenheit separation or more, depending on the sensitivity level the plant wants to set. Don't get too hung up on absolute temperature measurement accuracy, because in the end, that's not playing to the strength of what these cameras can do. We can provide, and we do have an option that will be released shortly, 0.5 degree C temperature measurement accuracy if there's a black body in the scene. But I can tell you that the plant I was just talking about is not going to be making use of that because they're perfectly comfortable looking at their entire employee population and understanding who's 2 degrees warmer than everybody else. That's the right approach, and that allows them to move people through the check-in line very quickly without placing a black body reference source somewhere in the field of view of the camera. Be aware that there are a variety of factors that can influence temperature measurement. Aspirin, Tylenol, ibuprofen, they all decrease temperature. They're all antipyretics, and whether you're measuring temperature with a core thermometer or an infrared camera, you will show to be cooler if you're taking those during a fever condition. Blood pressure medication can impact. Perspiration works very well to cool someone. Sweat works, and if your forehead is dripping with moisture from walking across a parking lot and climbing a long set of stairs at 90 Fahrenheit temperatures, you're going to perspire. Your forehead is actually going to be cooler because it's being evaporatively cooled once you arrive to be checked in with your infrared camera. So be aware of other medical conditions that might be impacting measurement. We haven't seen short exposures like getting out of your car and going right into the office building having a huge impact on temperature measurements. You can see we're measuring the tear duct area in both these individuals. My brother on the left with the beard, very normal temperature, 96.4. This is very common for someone who's in a room ambient. His son, my nephew on the right, was playing basketball outside in New York State, upstate New York. The temperature was 42 degrees, and he's measuring very cool. 92 degrees, so he's some 4 degrees Fahrenheit different. So you have to be aware that when someone's exposed to a very different ambient temperature for a prolonged period of time, it's going to have an impact on their measurement. A lot of people ask about crowd scanning, and this is an example of that. You just point the camera at a crowd and see who might be warmer, and it does work at a certain level. When someone has a high-grade fever and they're not too far away, they will show a temperature increase if your camera is set up properly. But we don't like crowd scanning because a certain percentage of the worker population could be compromised, or they could have a low grade fever. They might have a hat or glasses on that make it difficult for you to see them from above. And what we're trying to do with this whole technology is make it credible. And that means we don't want to be missing people that have low grade fevers. And as you just saw with the example earlier, if you can think about the number of people in 18 minutes, it was over 1,500 people in 18 minutes, you're really not slowing people down too much to stop and get a quick scan. This is the area where we're making our measurement right here. It's not only the hottest spot on your head, it's also correlates more closely with the core temperature than any other area. So this is what you're measuring when we're making a measurement with the camera. This is the camera that we'll sell more of than any other into the fever application, the PI 400i with a 29 degree optic. This is the camera that we right now have in large scale production that we're going to make available for sale within 3 weeks. And these are very important because the last thing that we want to do is get into an installation scenario with a customer where they get 30% false positives, right? You're not really increasing the speed with which employees are entering the plant if 30% of them set off alarms. So it is kind of important to make sure that this is set up properly from the outset, and we can really help here. We're gathering information on the best practices, and we do have a sense for how to make sure you get that right. We do want you to know that what we're doing here is grounded in some solid research. There was a work done in Hong Kong quite some time ago, back in 2013, excuse me, on 1,500 people that were in the emergency department in Hong Kong, and some of them did have fever. So they tested men and women equally, and they were able to find people with fever. They did not really set the cameras up optimally as we are suggesting, and they still found 87% of the people that had a fever they were able to detect when they rechecked them with a thermometer. Again, they did not do this with the right lensing from the proper distance, and they still were able to find. I think these numbers would be much higher with the approach that we're recommending. So there is some foundation for what works. The other thing they found in the same study was that the closer you are, your hit rate becomes better, and that's just purely a function of making sure that you're putting more pixels on the target. And you heard Chris talk about MFOV. Well, with a 382 by 288 camera, if you're putting 9 pixels in the eye canthus area, or about 3 millimeters, you're going to get a very good measurement. So we do say try to get 20 to 30 inches away. Boy, there's a lot of different policies out there depending on where you go about how you expose medical information. At the steel plant, they do not allow anyone to see the monitor with the exception of the security guard. You can see the TSA employee in the lower right-hand corner gets to see what's inside your bag. Well, at most facilities, they're allowing the security guard to understand something about your health by being able to see your temperature. So when you deploy these things fairly commonly, you might have human resources come down and tell you can't position the monitor like that because you might be exposing health information on one individual to many others if they're angled in a way that allows them to see the display. So you need to be sensitive to this kind of information sharing. So that's about it for fever screening. It does work. We've got several positive installations. These are going to be growing as we move forward. We recently, just yesterday or on Friday, AutoZone ordered a couple cameras for their distribution centers. CVS, the drugstore, the pharmacy chain, is very interested in placing units at their distribution centers. Distribution centers are very hot right now, excuse the pun. Amazon is of course dealing with employee concerns about being close to workers that may be affected. So now all of the other distribution centers are going through the same thing. And supermarket distribution centers, Amazon pharmacies, AutoZone, there's an awful lot of opportunity out there, and everyone is asking today, how do we protect our employee population? So I can't think of a more ripe market environment to sell into. And we're anxious to help. When you run into some questions, we're anxious to plug in and help. And Rick's been spinning up and his team on the applications so they can be of great help as well.